So I want to introduce our next speaker. He's a fascinating guy. His name is Micah J. He is a scientist at Intel Research. He is also the founder of a framework called OpenFL. And that framework is the best framework I've seen in the direction of FL that really understands a lot of the security dimensions of the sort of the workflows of how you onboard data and all the different sort of intricacies that you have to consider when you're doing this type of work. There's no point building these federated systems if you're going to sort of drop the ball internally in terms of these workflow managements and all the other sort of things like that. I always learn something every time I hear Micah speak, so I'm very excited to hear what he's going to say to us today. So Micah, can you hear me?
Yeah, can you hear me okay?
Yeah, perfect. Do you want to try sharing your screen?
Yeah, okay. Sorry. It's hard not to make a joke. So first off, before I get started, I want to
No, I'm curious about the joke.
Yeah, no. If I have to stop myself or I won't get through this presentation. So just a quick heads up. First off, actually, thank you for the wonderfully sweet introduction, Nick. The feeling is very mutual. Love working with you guys, and I look forward to more. Second, I should mention I'm recovering from COVID, so I will apologize if I just suddenly completely forget to say something and skip over some points. Call me out if something's not making sense, please. By and large, I love interactive presentations and talks, so if we got stuck on slide 3 because we had a bunch of fun conversation, that's a win in my book anyway. So as Nick mentioned, I'm a so can you see my screen? Am I sharing this correctly?
It's in this.
Yes.
I think you have to press the button to make it full screen. Perfect.
How's this looking? Great.
The floor is yours.
So today I want to talk about what I'm calling sort of the notion of collaborative development. And this really boils down to trying to understand how the many of us in this open source federated learning community can start to address the big picture toward actually enabling persistent, what I'm going to talk about as cross-silo federations, because they have tremendous world-changing, good of the world kinds of potential, and they need passionate individuals to drive them, and they don't always come with the best business models. So in some sense, I'm hoping to rally further support. This is much the ML Commons mission in general, around the idea of building a platform that really enables people to organize, coordinate, and collaborate on experiments, including once they're finished with one experiment, start another one shortly after. So as Nick mentioned, I'm from Intel Labs, but I'm also the vice co-chair for the ML Commons Medicine Subworking Group. ML Commons is really my sort of second work family. It's a great group. I got into federated learning actually through adversarial machine learning research that I was doing, and back then there was no FL framework, so I wrote my own, and I would say the 4th version that I wrote eventually became an actual supported piece of software by Intel, so you can check out Intel OpenFL. It is spiritually totally sibling of Flower. They're wonderfully aligned. It's really exciting to see how much our groups share vision-wise. I also, in terms of like past work, I mean, I've been at Intel since 1999, so I've worked on a million different things, but I think the key ones to call out is I served as the federated learning lead for a federation of over 60 hospitals that is gearing up toward its 2nd experiment. This initiative is driven out of UPenn with our research group acting as really tight, close collaborators. We're sort of the federated learning technical team, but I mean, we're almost one virtual team at this point. And I'm also currently the technical lead for the ML Commons MedPerf platform, which I don't know how much Peter talked about, but I'll mention some of what this is. It's federated evaluation platform aimed at enabling benchmarking of medical models against real world private medical data so that we can start to actually get an understanding of how models perform in the wild. This is obviously really important. And I'm generally just passionate about collaboration. It drives a lot of what I like to do and what I enjoy. I think a good way to sum up my personality is I'm the kind of guy who will put pictures of his crazy kids in presentations to strangers and give them nicknames such as Sausage and Gator. So those are my kids. They're amazing and crazy. If you ever want to talk about parenthood, I'm always down for that. So what I want to talk about, sort of the purpose of this call, it really boils down to kind of a call for collaboration, right? At the end of the day, what I'm hoping to do is give some sense, hopefully exciting, of the challenges that we currently have laid out in front of us, pique people's interest in which pieces they might want to engage in, generally raise awareness of what needs to happen. I think many on this call are going to be pretty ML focused, so there'll be parts of this that you're just kind of like, I don't want to do that. Hopefully someone else does it. But also people who have expertise in some of these areas who might think, oh, I could put that to use. And this really is driven by a desire to see this notion of a persistent cross-silo collaboration. This is where we're talking about things like medical research, that crosses international medical research, where you can actually have truly diverse patient populations in your training data. Educational research, international fraud's a big one. A lot of data silos you have to deal with there. And lots of other kind of good of the world stuff that it's going to struggle to get for-profit proprietary software to address, I think. But the reality is, among us, people who work in this open source world who have this passion, we generally have fairly limited resources. Right now, we have a lot of duplication of effort, and I think we're all probably keenly interested in coming together to bring our work together and really enabling us to sort of cover our own weaknesses with each other's strengths. It's kind of a way I like to think about it. It's like we've had this profusion. I think that's my next slide. It's just no, never mind. We've had this profusion of FL frameworks, and I think in some cases it's time to start merging, which I'll get to. So the one sort of level setting piece I want to do is talk about this notion of cross silo for collaborative learning or federated learning. Here, really, this is in contrast to a cross-device federation. In cross-silo, you have large, usually high-value data sets with institutions that have legal departments. They have information security officers. They have on-site experts in some sense, hopefully data science experts even. Your volume, your number of participants, a large cross-silo federation might be 1,000, whereas a large device federation might be millions. But on each site, you have people who are actively participating in the federation, at least in the near term. Maybe in some wonderful future that all can be automated. But for now, we're almost surely going to have significant on-site participation. And I come out of security and privacy, as Nick mentioned. I'm not going to go into great detail there. Don't have anything close to that kind of time to talk, but I'd love to talk more with people if they're interested later. And in the security world, we talk about the idea of attacks follow value. The threats come from the fact that there's something valuable to the attacker. And when you're talking about a hospital data set, breaching a hospital, infrastructure, planting a piece of malware inside a hospital is a whole lot more valuable than planting malware on someone's phone. So the attacker incentives go up. The legal and business agreements become a lot more complicated. You're no longer having people click through EULAs. You now have actual legal departments trying to exchange. I mean, it's a lot of work. And your dev and ML ops become significantly different because you are dealing with participating across what we call a trust boundary, meaning some of the ops people are going to be in another institution at another silo working with you. There's more, we'll leave it at that. But I want to finish this little description by saying this whole take is based on actually very limited experience and evidence. And that leads directly into sort of my next slide. We right now have this profusion of FL frameworks and very few federations to learn from. I have spent the last year basically just sharing my experience from one go at a large cross-silo federation. There is so much need to understand more about this use case that we need to try to move toward where we can actually deploy things, hobble our way through if we have to, and learn more. And right now, a lot of our frameworks are focused on very similar layers. They have different flavors. In fact, in this little arrangement from left to right, there's some amount of reasoning behind how they're arranged, which I might get into if I have time. But obviously there's Flower, which we all know and love. But there are others with similar missions and similar views. And I think it's time for us to try to inherit from one another in some of these places and turn our focus to building other parts of the components so we can learn yet more about the requirements, deploy more actual federations, and see what breaks, see what goes wrong. Apologies to those groups whose logos I didn't end up copying. I literally got tired of copying them. But they are also wonderful frameworks too. I don't mean to diminish them. So The experience that I'm drawing on mostly, this FETS initiative, FETS standing for Federated Tumor Segmentation, is really the baby of Dr. Spiridon Bacchus at University of Pennsylvania. It's through the strength and force of his personality and the level of trust he's built up within the community over years of talking at conferences that really was brought together this group of 60 hospitals, as you can see, all across the world. We had over 50 of them in the training portion of the experiment, and then the remaining roughly 10 participated in the validation stage. It was driven off of a pre-release version of OpenFL, essentially my own personal version at the time before I transferred it to the product team, with UPenn software built on top, where the UPenn software has been, something they've been working on for years that includes data harmonization, labeling, sanity checking, and a lot of other important tools. And the fact of the matter is that this took months to coordinate and run once the data was ready. It took probably years to get the data ready. We probably sacrificed, I don't know, a half dozen years worth of life from grad students who burned the candle at every end possible for unseemly long times, over a year with no vacation in some cases. And looking at the amount of handholding and shepherding and effort that this took and going, this is what computers can do for us, has motivated me pretty strongly to want to fix this a bit and not take so many years off the lives of these wonderful grad students the next go around. We are already over a year in getting the second experiment running. Ideally, by the time we finish that first experiment, it's a matter of a couple of weeks to start the next. And that's where I want to get. So a lot of work to do between where we are here and there. Quickly to go through sort of the major challenges that we faced. The biggest challenge, to no one's surprise, is going to be data, preparing it, how you label it, how you clean it. It's very hard. In our case, it was segmentation data. So the radiologists at each institution had to be trained on the same annotation scheme. There couldn't be some sort of centralized quality control, right? So some final sanity check that could be done. And it was based on years of work UPenn had done on this method for other projects where they've been getting people at other universities to use similar annotation schemas in order to create public data sets. So they already had a big leg up on making this happen. And the reality is this thing is full of opportunities for human error. And what we really need is tools that help monitor the process, make sure that all the stages are being adhered to correctly. Common problem. Radiologist busts ass, gets all the data ready, runs the sanity check tools, sends the email, I'm ready to go. In the meantime, oh crap, here are 30 more cases. Let me get those in there too, because more data is better. Forgot to run the exact pipeline. The data comes in, it's not registered correctly. It's not using the exact correct annotation schema, even the strategy for how to, like the amount of buffer to put on the segmentations. And all of a sudden the model goes to crap. We did not use a robust aggregation method. We actually intentionally stuck to just pure averaging to see how it would break. But we quickly learned how easy it is for things to go wrong when you just don't have really good bookkeeping. Additionally, monitoring tools, really important. And I put an asterisk here because the complexity that's introduced is security and privacy issues. Again, I'd love to talk about this. I'm really excited to hear the Brave presentation in the future. But for now, I'll just say that the short of it is the process needs to be that a sort of a central group of data scientists needs to be able to watch, or even engineers, needs to watch the global behavior, the global process, see red flags, contact the local on-premise experts, and then they need to be able to say, this particular error log, can you please investigate it? And the local person needs to be able to call that up on their local tool and get a whole set of rich details. They need wonderful, complete logs that tell them all the things that they need to solve the problem that they cannot share with us. And it needs to be a click to open it, because you would be amazed at how easy it is to be like, no, I meant the other log file. No, you looked, no, not that one, the other data point, right? We had some of this in place. It paid off handsomely where we had it, and where we were missing it, we wished we'd had it. One of the things we had was the ability to say, specifically, this particular data hash, that data point, something weird happened. It got flagged. Can you go look at it? And they'd look up in their table. Oh, that hash is this file popping open. Oh, look, half the brain just got completely blacked out for some reason. That literally happened. Additionally, provisioning and software updating. You find a reason why the model will not converge under your current federated learning strategy, and you want to add a regularization term of some sort. You want to make it sweet. That requires an update of some sort, and you need to push that out. And the InfoSec officers need to understand that that update is not going to violate any of their policies, and they don't want to have to reread a whole pile of code. So how you do this in a way that can adhere to the policies of the various institutions becomes quite a process. There's a lot of work to be done there, and you really need guardrails, or else the InfoSec people might say, hey, if you need to update, we're just going to shut it down because we can't afford to do this. So there's a lot of interesting pieces there. That was a lot of my own personal self-sacrifice, was finding ways to adapt the workload in a way that could satisfy the needs of the InfoSec people without requiring them to do any sort of reevaluation. And a big part of this whole piece is that we need, as much as possible, highly vetted common code. Bespoke tools don't scale well. They are essential. You have to have them. The experiments are going to be new. They're going to have novel code, but we need to modularize and minimize that stuff as much as possible. I'll give a quick shout out to the previous presentation about configuration through Hydra. Love that you're doing that. Love that you contacted them about support for byte types. I mean, that has been on my to-do list for I can't even tell you how long. It just warms my heart to see that, you know, hey, you've gone and tackled a problem that many of us, I'm sure I'm not the only one, have been wanting to see dealt with. I can't wait to go tell the OpenFL team that we can start digging into Hydra to replace. We have an equivalent bespoke version. That's not good. We have to teach everybody how to use our particular YAML config tool. They should just be able to use the same Hydra everyone else uses. Okay, digging a bit into this big platform and the component needs and why it goes way beyond where we currently are. Here is this sort of like horrific word cloud kind of deal that if you rearranged and started putting interface arrows and definitions and information flows, you might start to get to an architecture. Color coding is roughly sort of grouping of concepts. And I want to talk about a few pieces. First off, right now, there's a heavy emphasis on this algorithm logic piece and this DX, developer experience piece. And that's great. And we've learned a lot from doing this, and I don't want to discourage this. But let me say, without any kind of commitment, but I would not mind a future whatsoever where the Flower team was leading the charge on DX and how people interface, bring their code into the framework. And the OpenFL team could turn our focus almost exclusively to things like provisioning, governance, orchestration, experiments definition, these other pieces. I think that's a wonderful future if we can get there. I have no desire to have not in-house syndrome and decide that, no, you must use my DX, right? The sooner we can get past that kind of an attitude, the sooner we can start to build these pieces. And that really the point of this slide is look at all this crap. Each of these boxes could be developed by a different team with a work group in place with the other teams that they have to interface with to define the interfaces and requirements. I think this is entirely possible in some future. It's the kind of thing you might do in a standards body if we actually knew what to do. But right now we need to just hobble our way towards trial and error and learn more, because again, I'm basing this talk off of what really amounts to one major federated learning experience. And so the hope here is that you can see some of these pieces and maybe it piques your interest. You can understand your needs, so you know, like, okay, I don't want to do that. I want to go connect to a group that is doing it and figure out how we can work together to prevent me having to solve that problem. And I put some asterisks by the words federated on this slide. And I want to call special attention to them. One of the big pieces right now, and if there's anyone on here who's dealing with distributed compute and has any expertise there, we really need distributed people to come in and tell us how to adapt existing tools to the federated trust model. Because right now, the trust model that we have in the collaborative learning community does not map well onto the existing set of cloud and distributed tools. I have tried so many times to reconcile the limitations, the security and privacy limitations of existing tools for things like registries and monitoring and so forth, and it's just not there. But it may not be that far, and an expert might be able to say, oh, I could do that in a couple hundred lines of code and you've got what you need, and that would be phenomenal. So we have these things that resemble, these needs that resemble existing tools, but just aren't there quite, and it boils down to the trust model, how policies can be defined, and really support for clean and clear access controls. They don't even have to be all that complex, but that will cover the fine-grained needs, meaning you can be very specific about what access controls are, and it's something that an information security analyst at a hospital has the time to read over and actually match to their internal policies and nod their head about, other than go, oh, this is way too much, and throw their hands up. I've also put in bold registries. This is a piece I want to sort of explain to get at the ML Commons and MedPerf side. Registry is sort of a general term for a place where you're going to store some information that tells you things like who are the people participating in this collaboration? What stuff do they have, be it data, code, or event logs? What was the last piece? Oh, what have they run? Where are we in the workflow? What pieces, what should I evidence of the actual activity should be able to find? This gives you the ability to do things like auditing, like monitoring, fault tolerance, other kinds of analysis that also potentially helps make very clear what information is going to be public and start to define access controls. It needs to follow the same sort of general pattern as the monitoring, where you have this sort of like, you central data scientists need to know that 10 batches were run at this node in this last update, and something weird happened. And here's the signature, the hash of this event. And now I can say, I know there exists a log on your system that tells you about what went wrong. Could you please look into this for me? You get this for data as well. It's a big one, what data sets are out there. This also ties into data cleanliness. I want to know who has what data and what sanity checks they've run. I want to know that the fact that the system, this private data interface is down at the bottom, wants to be able to say, oh, you added 30 new cases and I don't see in the registry that you ran the sanity checker on that. I'm going to raise the alarm and stop the process before you corrupt the model. Running out of time to cover more of this stuff, but there's this pile of needs that I think we can start to really work on together that can drive us toward the ability to actually have something manageable and realistic for persistent federated experiments, which I'll throw in another piece. Everyone here, I think there's a large audience here anyway, that loves to talk about aggregation strategies. Our research up to now, none of us should be surprised if it's all wrong, because it's at root an empirical science, and we really won't know anything until we've got way more data points on real world data than we currently have. So I think this platform is when we will, in some sense, grow up or level up in terms of our research on aggregation strategies, when we can finally get our hands on messy real world data. Okay, running out. Okay, I'll try to move faster. So how do we get there? Obviously, I don't have an architecture proposal, nor should I be the one to present such a proposal. I wanted to give a big picture idea, and I've alluded to the fact that there's a lot we need to learn along the way to understand better what those interfaces and big pieces should look like. And so now I just want to talk about a couple of baby steps that are heading there. So the folks at Flower are phenomenally wonderful people. Been having a great time working with them, and again, the OpenFL team and the Flower team see so eye to eye on many things. And additionally, with the MedPerf group, like the federated evaluation platform I was discussing, we have an opportunity to start to put together some of these ideas. MedPerf right now, for the sake of federated evaluation, has this concept of ML cubes, which I think you heard about earlier. And it has these registries to register the fact that there exists data at this node with some very high, here's some very high level summary statistics about it. And here are the tools and checks that have been run against it. We can use the same mechanism that we use to provision and govern a federated evaluation experiment to also provision and launch a, I won't say govern, but we can at least launch a federated learning experiment. And this is something ML Commons wants long-term. We want MedPerf to also support FL. And we can get there by basically creating a little shim. I hope in the next month to have a proof of concept that shows what I'm calling OpenFlower, and that's sort of like the combination of OpenFL and Flower, where you can take Flower and OpenFL federated experiments, have them described and registered with the MedPerf server such that anyone who's part of that MedPerf server instance, has a user account, has relevant registered data, can join the federation, and through MedPerf and the MedPerf client, pull down the required software, connect it to the correct data, and then begin running the experiments. And if all goes well, this little purple bit will be the only novel code that we even have to add to what we currently have, and it will hopefully be small. And it will start to show how this can happen. If it's not small, I'm going to learn a lot about where the interface gaps are. And through this, we're going to have a proposal for what should this container interface be for a FL agnostic federated ML cube. When I say FL agnostic, what I mean to say is framework agnostic. We've had those conversations between OpenFL and Flower, and as we do this, I want to grow this out to other frameworks, other participants, other people. What are we missing, and how can we improve these interfaces? Oh, sorry, I should mention what's particularly cool. This gives us at least some form of registration, provisioning, and organization for both OpenFL and Flower, and hopefully a small amount of code. And this is my last slide. Another topic here is second to last slide. Flower and OpenFL integration that we've been working on, where we have right now a POC where with this YAML this YAML file on the left, this is a Open Federated FL plan, which is an analog to the Hydra Flower baseline thing that Pedro was talking about. Again, I would love to just harmonize the way we do those two things. No reason to have two different structures for this. And through these YAML lines in an FL plan, you'll see the CFAR client. Many of you probably know that tutorial example for Flower. No change required to that guy. It's just this YAML file. And now an OpenFL Federation can use a Flower client. So if I've written a CFAR client for Flower, and for some reason or other I need a feature that I want to use OpenFL for, I can do that without any change. I want to make it go the other way as well, where OpenFL clients can be used within Flower. Here, but with just this little example, we're looking toward a future where perhaps we have Flower client developer experience support with potentially OpenFL platform features, such as some security, governance, these kinds of pieces that we're working on. And the next goal I want to do is direct interop. We both use gRPC. We have very similar protocols. Can we harmonize those protocols, or is it simple enough to create shims? And through these POCs, illuminate the interface needs. What are the RPCs you generically need for FL, and can we all agree upon them? And now I can bring a federated learning framework that supports one kind of platform into a different framework as a server. And the best example I can give here is OpenFL does not have the richness of client platform support that Flower has. I want to see if we can have a win where Flower clients talking to OpenFL servers means now those platforms can now integrate into the same federation. Note, this PR was not submitted. I really wanted to have it. I really wanted to be able to point everybody to the PR, but I'm going to blame COVID. So, all right, wrapping it up. ML Commons is that's right. ML Commons is actually an essential piece of all this whole story, because this really is my hope for where we can fill this critical gap of this neutral ground. They really are a group that has this mission to do good. They see themselves as exactly the kind of players to help bring people together who want to work together, but it's maybe a little difficult or tenuous how to do so, especially within an industry. And right now we're UPenn, Flower, OpenFL, we're working together, and MedPerf, working together through the medicine work group. And there's been talk, and I have hope for moving toward an actual collaborative learning work group where we can begin to really organize how we're going to work together. And I kind of have this mantra: collective strengths covering our individual weaknesses. So I think I'm over time, so I'll stop there. Thank you very much for listening.
Thank you, Micah. That was great. Questions from online or physical folks? I guess I had one question. Imagine I was starting a PhD and I was going to do federated, and so I probably would start comparing the baselines and try to shift the curve. What would you tell me? I imagine you might say, don't do that. What should I do?
Okay, so if what you want to do is, in my opinion, to really help move the science, is you join an effort that's working toward open collaboration. You join an ML Commons type of group. You join up with the Flower group. You align yourself with these efforts that are really trying to move things towards real world experiments, reproducibility, real world data. I don't want to dissuade anybody from running over synthetic or public data. Maybe we'll call it toy data sets. That's important work. It's done a lot to get us where we are. But I would want to set and tamper expectations. Most papers don't change much, right? Most ML papers end up being not worth much in a few years. And in our field of collaborative learning, with how empirical everything is, because we can't prove any of this works, at least not for non-convex models, we just can't make very strong claims without significant empirical evidence. So we need to build that platform to do the science. And I've been finding there are PhDs out there with this passion, and they've been joining up with the MedPerf effort. And I think that will prove to be a more significant contribution long-term than, I don't know, not to trivialize it, but yet another application of existing regularization techniques to federated learning with a small tweak. I mean, it's good stuff, but it's not going to get us to where we need to be to really open the floodgates and see and realize the value of this. I mean, look at the fact that we've been at this federated learning game for how long, and we have almost no real federations. If you were in the game in 2017, the prediction was that banks would have been all over this by 2019, and it's just not really happened. And there's a reason for it. So yeah, I don't want to trivialize current academic research. It is very important. I do think it will really become a lot more meaningful as we find a way to operate on real world data. These flower baselines are a great thing, and I want to make it so that you can then take those and deploy them on an existing group of collaborators that have all registered with MedProof. Now your experiments can actually be run on real world data.
See, yeah, very makes sense. I agree. Next question is from the online world. Where do you see the biggest impact for FL? Oh, where do you see the biggest impact for FL, and in terms of what it can mean for the world?
Oh, okay. So near term, the biggest impact is really going to be around, I believe, around. Oh, I'm so biased because medicine is near and dear to me, but it's validation and evaluation to start. We're going to learn how bad our models are. We've had people recently die because medical ML models were so poorly validated. There's so little visibility into the methods for that validation, and the FDA is scrambling to figure out what to do about it. And when it comes down to it, our only really, I think, surefire bet is tools that allow us to actually test on real stuff. Once we start doing that, we're going to find, I think, how lacking many of our solutions are. And that's when FL and federated analytics and data quality checking tools are really going to start to come to the fore. So I totally biased from a medicine point of view, but I think many of the AI models that we want to create are really never going to work until they are both validated and then improved by federation. I don't know if that really answers the question all that well. If you're looking for a domain specific answer, I would say that I'm the wrong person because I am much more of the security privacy frameworky type, but I do believe medicine is the first mover and there's tremendous potential there. That's where my passion lies too, personally.
I was wondering, do you think you can push that argument all the way to the end and say that eventually all machine learning models will need to be tested in a federated manner for them to be verified as working, even if they're trained centrally? Because that's only then will you understand if they really work in the real world at a level that is reasonable, can be certified.
Mm-hmm. For mission critical kinds of deal, I think it's going to be a necessary component, probably not sufficient, but at least necessary. We are so slow to adopt AI, and I think it's for good reason for mission critical work. The way that I see, I shouldn't say I hate using that term. The way I see ML succeeding in the world right now is through non-critical tasks, where essentially, I mean, okay, without naming companies, we have a number of models that work great right now that started out as ad campaigns that were terrible, that were just basically pushed at us like, this will work, trust us. Well, it didn't work for a long time, but people used them because of the ads. And eventually, through a lot of in the field testing and updating, which is essentially what you can't do for a lot of these use cases without FL, those models found their way to being good. And now a lot of these things work wonderfully that didn't work 10 years ago or 6 years ago. What am I saying? So the analog for those scenarios are where you have a giant user base for your service. And some of those scenarios gave birth to federated learning. Not to say that Gboard was terrible for federated learning. I don't want to make that claim at all. But the sort of cross-device use cases were about this in the field, in the wild, is the only way you actually get an ML model to any sort of real fidelity and utility. And when the data is siloed and highly valuable, yeah, I think it's going to be the end game for a lot of this. Or I'll put it this way, it's one of the possible end games. I can't promise that it will work. I mean, federated learning is not going to solve all ills for all projects. We're likely to find use cases where we put together all the data in the world and it doesn't suffice, right?
I like to see what happens.
What's that?
I mean, I'd be curious to see that'd be the real limit, right, of the learning. If once you get all the
Yeah.
data and then doesn't learn, well, then we've reached some point.
Yeah, adversarial machine learning, I think, almost by itself proves the existence of such use cases.
So another question would be, will we ever be able to give a privacy guarantee, something many people like to ask about, with specific DP settings? So do you think DP settings, I guess I see.
Okay, so I'm going to try not to soapbox about this. Differential privacy settings, possibly. Having a particular DP setting and mapping that to privacy needs is a monstrously large gap. Differential privacy is wonderfully formally defined mathematically. Its map to real world privacy is horribly hard to understand. And ultimately, differential privacy ties into data confidentiality, which is just a relatively small portion of privacy. Privacy for most folks means the freedom to not be disturbed when they don't want to be observed or disturbed, but disturbed is the bigger one. What's pissed people off the most? And it's cases where machine learning has been used to discover things about them that they didn't want discovered through their public information. That's model outputs. That's not training data inputs. So the actual correct use of public data to not infer private information, that's the real killer in privacy for ML. DP doesn't help. DP is more like proper stewardship of data. So I don't want to minimize it. I do love its mathematical properties. Realizing meaningful privacy guarantees using DP and federated learning is again going to be a component of a much larger set of requirements, and is more like something we have to do and require of ourselves than a full solution. And as far as the epsilon targets, boy, that comes really hard. You have to talk about the granularity of records and a whole lot of other DP settings, because DP is not a binary works or doesn't work thing. It's very much an analysis where the numbers matter a lot, and your numerators and denominators can be scaled tremendously different based on small, seemingly innocuous differences in use cases, to where predicting where it's going to work and not is a fool's errand. And on top of all that, it's an exponent. And on top of all that, it assumes an attacker model that's impossible. So what you see in the world today, by the way, is every epsilon is entirely too large, and the response is, well, under empirical analysis, it held up, so that's cool. In which case, I want to say to everybody who says that, great, then stop talking about your epsilon and start talking about your empirical analysis, because your entire statement is based on that. There's my soapbox, I'm done. But yes, that's a near and dear to me topic, and I'm actively engaged in that work as well. So if people want to talk on that in the future, please hit me up.
Thank you. Well, I think we're kind of run over time a little bit, but it's been great hearing your thoughts, and also the Q&A was really engaging. So thank you for your time, and let's thank our speaker again.
Yeah, thank you all.